There was always a limitation of SQLite. SQLite only works on a single machine because it's just a file. Now you can have like 5, 6, 7, 10 thousands of different applications using the database. All of them have their own SQLite files on disk. They're all writing to the SQLite file, but they're all like periodically receiving the changes that the others are making through the sync mechanism.
Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. Really excited today to have Glauber Costa on. Glauber is the CEO and founder of Turso, and Turso is a service for both. They have a fork of SQLite, and it's a service to distribute and use multiple SQLite instances in different regions, and really, really interesting product. We're really excited to talk about it. I'm a huge fan of SQLite in general, and it's super exciting. But before we dig in, would you like to tell our audience a little bit more about yourself?
Absolutely. So first of all, thank you guys for having me. Like we had a couple of scheduling issues, so it's great to finally be here. As Justin said, like my name is Glauber Costa. I've been working in the software industry for around 25 years now, and give or take. It's funny because like when I started, the world was also falling down for the 2001 things like that. So like everything that's happening now, it's not my first rodeo, and I just want to leave a message to the younger portion of your audience that it's gonna be fine. Like it's gonna take a while, and it's not beautiful in the meantime, but it's gonna be fine. But like back in the early 2000s, the world was very different. Software was very different. And I took an interest in the Linux kernel. So I started, that's how my journey in my career started. I started contributing to the Linux kernel. I was in school and I liked it, and why not? So let's just do it. And I think around 2004, then I was hired by Red Hat 5 or something like that. My memory is a bit fuzzy on that. But around that time, I started working for Red Hat, so I started doing that professionally. And I spent around up almost until 2013 in the Linux kernel. So I worked with a variety of things, with containers, with memory management, with the x86 boot sequence and stuff like that. That's where I met my co-founder, by the way. My co-founder was also in the Linux kernel, Pekka. And we joined a startup in 2013. I joined as employee number 3. Pekka joined as employee number 4. The startup was doing something that didn't work at all. So we went through this experience of we spent 2 years doing something nobody cares. Also like a deep tech and etc. So it's not something that you can iterate that easily out. And after 2 years, like nobody cares. And then the company pivoted to a database called Scylla, which is a database in the NoSQL space for like high performance, very large data sets in the petabyte scale. And again, this is how Pekka and I got exposed to databases. And we spent together 8 years doing that. In late 2021, almost 2022, we decided to found this company. Much like our previous company, our first product also quite didn't work. But we thankfully, and I think in part because we had this experience, thankfully we found that out a lot sooner than 2 years. And our product was using SQLite. So we were using SQLite in the product. And this is something super fun about like how startups work, etc. Sometimes you get to the idea, like the stuff that you become by accident. I mean, I had no intention of especially like after 8 years of Scylla, and I love him. Like the database market is a hard market, and I was like, I don't want to do this. In fact, when we started the company, I said, Pekka, what are we gonna do? And I said, everything but a database. Okay, let's do whatever you want, but let's not start a database company. And here we are, because we were using SQLite, and then we hit into a bunch of stuff that we didn't like. We can go into more details later. And then we published this fork of SQLite as part of our previous product to say, hey, like I just not as part of the product because the product didn't care if it was SQLite or the fork; it was all hidden. But we're like, let's be good community members, and let's do our community job here. That's the way to play open source. So we put this fork out, and lo and behold, 5 days later, we have like 1,500 GitHub stars. So we started noticing, okay, so there's, damn, Pekka, we're going to become a database company. and here we are.
Yeah, you've certainly chosen some hard problems to spend your career on. Linux kernel development straight out of college. But I have to ask one question about that. Have you ever personally been chewed out by Linus? Like, I know that's like a dream for many a developer.
By the way, this guy that's on the news right now, Steve Rosted, great friend of mine. He's a great guy. And it's a little bit unfair. I mean, I actually I found the web post. And he's a great friend of mine because when I started my career, as I said, a very young junior guy, he was way more experienced. He was working at Red Hat. So he took me as a mentor of sorts. So like we still talk, not as often, but, every now and then. It's a little bit unfair that he was put under fire. Like, and he explains his reasoning in that post. I recommend if Google just I think it was on the register. So Steve Roster, Linus, etc. You'll find it. But not by Linus. All my interactions with Linus were very friendly, and this is something a lot of people don't realize about Linus. Linus is not always like that. And even back then, I mean, they claim he's better and etc. But actually, the normal baseline Linux is not like that at all. It's just that the Linux kernel is such a high volume thing that this happens very often. But I think I always walk the line well. What did happen though is and this is you might have heard that I've heard this phrase once. I mean, it's absolutely true. Every startup acquires the personality of the founders. This is 100% true, and it's not true only for startups. The Linux kernel had lots of people adopted this very aggressive stance because of Linus, because this was his personality. So I was flamed a lot by other people, but I didn't have the one time in particular. It was a very, very bad experience. It was likely one of the things that led me to the decision of just when I got this offer to do something else, I just said maybe I should give it a try, because it was a very unpleasant experience. And that was with the maintainer of the networking stack, which was a stack that I was not very familiar with. So I started doing some work there on behalf of the memory management subsystem. I did not know him well. I did not know him, how he operated. I did not know the code. So I started doing a lot of stupid stuff. And I got, I've got that times 3, but not from Linus. Linus was always very kind to me every time I had to interact with him.
Well, it's great that it was kind to you. Yeah, the messaging around that ecosystem has always been interesting because, he does have those famous blow-ups.
But again, I had many friends. That were flagged by Linux, and this that happened with Steve was I think I just got lucky, as I said, because I never interacted too much with the subsystems that Linus was more active at. So every time I had to interact with him, both in person and over the mailing list, it was very kind. But I had every single week there was somebody at Red Hat that I consider a very good personal friend. It was always a rite of passage. I didn't have that, but and I was flamed by other people as well. So it was a very unfortunate but very true reality of the Linux kernel. I don't know how things are today, but I know there are very good people in the Linux kernel that don't behave like that at all. Andrew Morton is one of them. Andrew Morton at the time was pretty much the second person in command of the Linux kernel. I never seen that guy behave like that. And Jens Axbol, it's the person behind IOU Ring, which is one of the coolest things in Linux in these days. He's the softest person you can imagine as well. So not everybody is like that, but it's fairly common.
Well, let's switch over and talk about SQLite a little bit. So SQLite is a really famous database. It's the most widely used database in the world, probably. And it's one of the things that it's famous for is both it has a small team and it's open source, but it's not open contribution. So it's you can see it, but you can't touch it.
Well, more or less, you can touch it, which we did, because there's no because just to clarify, because there are licenses, there will be like this. You cannot modify the software, etc. SQLite actually has no license. They're public domain, so they cannot legally. And the public domain thing is interesting because one of the things SQLite has no dependencies. libSQL has some dependencies, and one of the reasons that they claim is exactly this: we want all the code should be in the public domain, so we're never gonna be touching a dependency. So the code is public domain. We can touch it. but it's just that your code is never making it back to SQLite, right? Just
Right.
you can touch it, and this is your fork. That's what we did, but it's not part of SQLite. They're just not interested.
Could you talk a little bit more about the fork libSQL and why you made it?
As I mentioned, like we were using SQLite in our previous product, and we were interested. So the intuition that we had at the time is still with us with Turso. It's like, again, we were not a database company, but we were doing like the data replication and data at the edge, and we were trying to do a bunch of stuff like that. And we knew that SQLite was a part of the puzzle, because SQLite is very cheap to run. In fact, when it's not running, it's free, because it's not like a normal database it's just a file, right? So it's not like a normal database that it's always needs to be running, taking connections, and etc. And we knew that we could do data replication with SQLite. So technically, we kind of knew how to do it. We said, like, this is super easy. You just hook in here and in there. So we actually have those hooks in our fork. Then you write the replication algorithm and plug it in here. So we had the mental map of like, how do we do data replication of SQLite? And the problem that we were tackling at the time is exactly this problem of if you're running code at the edge in like 20 regions, it's fairly slow from some of those regions to get to the main database. So that was the problem at the time, again, in the context of our previous product that we were trying to tackle. And we found a bunch of people that were trying to do replication of SQLite. So we found, first and foremost, okay, we're not the only ones trying to do it. So we found like SQLite by Canonical. We find like LiteFS from Fly.io that Ben Johnson is heading today. And SQLite, for example, the way they solved this problem was very similar. Now, they have stronger consistency guarantees, so we didn't want the full solution. But we would be fine. By the way, we could have just used that. But they had a bunch of hooks in SQLite, and they tried to contribute those hooks back. And they've got the usual, bye, go away, we're not interested, like take your path back home. We want SQLite to be this thing here. And LiteFS is just not an architecture that we wanted to do, because you cannot change SQLite. They are essentially a distributed file system. And there were a lot of problems for us and a lot of technical reasons why we did not want to manage a distributed file system. Chief amongst them is that how are you going to run this on Cloudflare workers and the edge things that we were pushing forward, right? So look, one day, like Pekka and I were chatting, and I say, you know what, man, just our first idea is like, we should just rewrite this whole thing. Like, let's just rewrite SQLite in Zig, make something like that is compatible with the file format, compatible with the language, and we can use some of the code, and hopefully, Zig will allow for us to get C code fairly easily. Let's just do it. But then we started thinking, and we started, and we were like, oh, look, we're not doing this for the goodness of our hearts. So we're running a company, and we have a product that is doing okay, but not that well. The growth wasn't there. So it's not like we can spend like a year and a half just rewriting SQLite on the side while doing this. It's not going to work. So the second idea that we on this iteration is, okay, so instead of rewriting it, what if we just fork it, right? Because then you are like compatible from day one, and you have a product from day one, and you just make the changes that you want and go from there. So this idea started to become more and more exciting for us. But here's the thing. Given our experience with Linux, the first thing is that we were just absolutely not afraid to fork SQLite. Because I think lots of people have this thing about, hey, SQLite is this holy piece of software. And it's a fairly small code base. It's just C. Like there's nothing magical there. And again, we had this example of a community project that had people from all over pushing this project in different directions from Linux. They say, hey, this is what we will, in an ideal world, this is what we would like SQLite to be. So we figured like that if we were to maintain a fork that was like SQLite plus this technical, SQLite plus replication, there were many forks of SQLite like that. There were like I found later a guy that was doing like SQLite with encryption, and then like SQLite with this. If you go look for forks of SQLite, you will find many, because again, the code is public domain, so you will find SQLite plus this. I think what we realize is that this is not the way to play. The way to play is that we're going to first create a community. So we're going to announce a fork of SQLite that is just like the fork of SQLite for whoever wants to build anything with this. And then on that fork, we're going to do our stuff. Like, we don't have to do stuff for other people, but if we can message and signal that, hey, if you want to try stuff and you're also frustrated, you can come with us and you can do stuff with libSQL. So we were flamed on Hacker News, and then again, like, people that did not know, I worked in Linux for 10 years, maybe thought that I was somehow affected by that, but I was like, yeah, whatever. But we were flamed a lot on Hacker News. One point specifically, because when we announced the fork, we didn't write any code. Like, we said, what is the minimum? We thought this very thoroughly. What is the minimum amount of code that you have to write to validate the idea that this fork is a good idea? And we understood that, the minimum amount of code is 0. You don't write code because we are attacking a community problem. So you don't write code to attack a community problem. And actually, if you do, it may be counterproductive, because you will become, in the eyes of many, the SQLite plus this, which is what we did not want. So we wrote no code. We just changed the license. Like, we added a license, which you can do because the previous code is public domain. So we added a license. We wrote a code of conduct, because SQLite infamously or famously has a joke code of conduct. It's an actual joke. So it's a refusal to have a code of conduct, so they put a joke in there instead. And we put a manifesto out saying, hey, look, we're gonna have a MIT license. We started with Apache, but then we changed to MIT. We're gonna have this MIT license. We're not gonna have the same policy as SQLite of like no dependencies. We will take dependencies wherever needed. We will keep the file format the same, but we reserve the right to change other things. This is things that we might want to change. This is things that we don't intend to change. And this is libSQL. Now come and build with us. And this happened in October, as I said, October 2022. This got like 1,500 stars in 5 days, which was more than what our previous product had after a year of development. And then we said, damn, we're a database company now. So it's not that simple. I mean, it still took us a month or so to kind of say, come on, are we doing it? Is that what we need to do? But it became clearer and clearer that that's what we needed to do.
Now, we'd like to thank our sponsor for this week, CodeCrafters. Without our sponsors, this podcast wouldn't be possible. CodeCrafters makes programming challenges for experienced software engineers. If you're looking for a weekend project that takes you to the edge of your programming abilities, you have to check them. They've got a bunch of really fun challenges, such as build your own BitTorrent, build your own Git, build your own Docker, and so many more. They have the challenges in a bunch of different popular programming languages. I'm using JavaScript. If you ask me, it is a great way to build your skills, and it's way better than just grinding on leak code. You get to dive into the inner workings of popular dev tools, and at the same time, become a better programmer in your own domain. I've been working through the Build Your Own Git challenge using JavaScript, and it's been a lot of fun. I've learned about the binary format of Git, and fun things such as the head is just a file. It's just a file that has a reference or a SHA in it. So I've always wondered, how do you get into a detached head state? Well, your head file just has something in it that isn't on a branch. Really interesting. One other cool thing about doing these exercises, especially the Git one, is I can just look in the Git files to see the format for things. Like, I just wrote the git commit tree command, and to do that, I just looked in my Git objects folder. My .git folder has now become a thing that I kind of understand and can reason about pretty easily. Besides that, the user experience is also wonderful. You don't really do anything on their website. You go read a prompt, they may link you to some docs, but mainly you're just in your code editor trying to figure out the format and the tool that you're implementing. To try out CodeCrafters for yourself, visit codecrafters.io/devtools-fm. There you'll get a 40% discount, and you'll also be supporting the podcast. We hope you check them out. If you're looking for another way to support the podcast, you can head over to shop.devtools.fm. Over the past few days, we've released some pretty cool pieces of swag, with more to come. This week, new on the store is an anti-DevTools DevTools Club hoodie. I think this message is really funny because most of the people we talk to kind of fall into that. They're against another dev tool, so go try this new dev tool that fixes all those problems. So I think that sentiment is very, very near and dear to our hearts here at DevTools-fm. Do you want to sponsor the podcast yourself? Head over to devtools.fm/sponsor to apply. And if you want all the latest DevTools news weekly and a little bit of recap about our episode, head over to mail.devtools.fm to subscribe to the newsletter. And with that, let's get back to the podcast. So were you guys successful in that? Like, did you foster a community and like have other people contributed to libSQL other than people that work at Turso?
So we have, depends. I think not, because my benchmark is Linux, right? And so I wanted like 10 companies building products on libSQL, and that did not happen, at least yet. Now, it also took a long time with Linux, but we do have on GitHub like more than 60 contributors today that they're contributing to a variety of aspects of libSQL, the server mode, the drivers, etc. So we do have a very healthy community of contributors. So again, I think I had very high, given how central SQLite is for a lot of things. I think my dream scenario did not come to play, but I'm very, again, this is just because my bar was very, very high. I think by and large, we were very successful with that. We have, as I said, on the core project itself, not to mention the language SDKs, on the core product itself, we have, I think, around 60 contributors today.
That's awesome. So you got to start somewhere, and it's infinitely better than what you're competing with of 0.
Absolutely. So 60 people is like 20 people more than 20 times more than SQLite. SQLite, I think, has 3 people working on the project.
Yeah. So I'm a front-end developer, and I gotta admit, I have not used SQLite all that much. So I don't really know like the properties of it that make it like a nice technology to use. So for people like me in our audience, could you like kind of go over those? And then after that, like I saw that like what you guys have done with libSQL has like kind of unlocked some cool new use cases, like running a database per user. So could you walk us through some of the cool things that libSQL unlocks too?
This was actually already, the database per user was already a fairly common pattern with SQLite. And I will get to the cool things about SQLite in a moment, but just to touch on this point, our architecture didn't quite allow that when we launched the Turso server. And it's really like, Turso is essentially, you can think of Turso as not a database. And again, I always try to fool myself into say that I'm not running a database company. So you can think of Turso as a web server. So you send HTTP requests to that. But in that web server, like there's a SQLite file there, and that SQLite file gets replicated. Technically, it's a libSQL file, but again, the file itself is SQLite. And then we have the replication hooks and algorithms and etc. And there are some files related to replication. So it's a web server. You connect over HTTP. It works from anywhere. It works from Cloudflare Workers. It works from Vercel, Edge, and whatnot. So the first version of this server, and the server is also a part of the libSQL project. This is all open source. It's not that we have the fork and then like the server is also part of the libSQL project. It comes with when you go and compile libSQL, you would have both the library database and the server. Our initial architecture, the server was serving one SQLite file. So the server goes on a VM and the VM had one SQLite file. And then we offer for free like 3 databases for people to get started. So, but people came and asked us many times, okay, since you're based on SQLite, why can't you give me 10,000 databases? Why can't you give me this many databases? Because this is already a pattern that's fairly common with SQLite. So we did the work to change the web server to now be multi-tenant, so that you can route requests to, you now can create all of those files, and then you can route requests to the right file, right? So we've done that work, and then we unlock this use case. But it is, I just want to highlight that it is a use case that people came and asked us for because it's a very common pattern with SQLite. Now talking about the good things about SQLite, why? Because SQLite, at the end of the day, is just a file. So creating a database in SQLite is just a file. You only pay for stuff you use, because again, think about it. If you write like a Node.js application, SQLite is just a library that you put inside your application. So the existence of that file in the file system does not consume any resources, except of course for the disk space. If the database is never queried, your Node.js application never spends any compute cycles on that. Right? So it is already a pattern that because of that, like people. So again, it's very easy to work in a serverless environment with SQLite, because again, it has this property already. Like you have to write a serverless server, which is the oxymoron to an extent, as we did, right? But once you have this server running, it's a serverless architecture. The database is Like there's no cold start or anything like that. The databases that are not being used. Now we do have cold starts for your group of databases. If you don't use any database, we shut you down. But you want to create 500 databases, the database they're not using, boom. When a request comes to the database, you route to the database. So fully serverless, right? The no code starts. It's a very good architecture. SQLite and because of that, SQLite has been traditionally used in like mobile devices, low power devices, industrial controllers. So it uses like an iota of memory. It's an incredibly efficient database. So again, it allowed us to put a plan out. Our free tier offers you like 9 gigabytes, 10 billion rows read per month, etc. It's like crazy numbers that people keep. And I can tell like our cost to run our entire free tier and our cloud costs are like $3,000 a month at the moment, which is like nothing, right? Just so we can run this, and we already have more revenue on the paid plan than that. So I mean, it's a very cheap database to run. Now, not that we are profitable as a company because you have to pay people, and that's the expensive part. But like the cloud bill for database companies are usually like the super expensive part, but not for us. So it's super cheap to run. It's incredibly fast. And when you don't use it over the network, which is how SQLite is traditionally used, the database responds in microseconds. So you don't have to be afraid of like N+1. And Turso has a mode where you read from a local file, and then Turso does the work of keeping that file in sync. So that exists, right? So you can take advantage of that property of SQLite as well. So it's an incredibly fast database, even over HTTP. Like usually Turso responds if you're coming from a close enough region. And then again, replicating because of the same thing. You create a replica, you're not really creating anything until you use it, right? You replicate our basic plan in 3 regions. So for free, you can have a database in 3 regions of the world. This is like unheard of. And usually you're talking about like 10 to 20 milliseconds for a request from Cloudflare workers, from Vercel, etc. So it's fast even at that. It's fast if you're talking to a local file. This is like 0 latency. Node.js doesn't even have an API, as far as I know, to measure latency in microseconds. Like 1 millisecond is does, but it's just super fast, cheap to run, memory efficient, and it has this property that lends itself to a serverless architecture very easily, right? That is, at the end of the day, at some level, this is just a file.
Yeah, it's really, really fascinating. So cool. If someone let's say someone has an application and they are using SQLite already, and maybe they first want to migrate to using libSQL. You mentioned earlier that one of the goals of the project is to keep the file format consistent. So from that perspective, there's nothing that has to happen to change on disk. But what other work has to happen to do the migration? I'm assuming they have to use like a different SDK or different driver.
You have to use so you have to use a different SDK. And I think a lot of people don't realize that. People ask us, but aren't you compatible with SQLite? But if you write a database, there's a clone or a fork or whatever of Postgres. The database is over the network. So you can keep your code the same as long as you keep the wire protocol the same, right? Because the database is on the other side. With SQLite, this is actually impossible because the database is the SDK. Like replacing the database means replacing the SDK. Like there's nothing else that you can do, right? So to replace and this is one of the weak points I think of at least I'm not concerned about that in 2 years from now, but because we have limited bandwidth, we can't have SDKs for all languages. So we have it. We focus a lot on 4 languages, which is the TypeScript/JavaScript, Rust, Go, and Python. But we see a lot of people asking for like C#. C# is incredibly asked for. I think that people probably do a lot of IoT with that. Don't quote me on that, but I think that's where we get the spool from. People ask a lot for PHP. People ask a lot for Ruby. So again, we don't have those SDKs, and we hope to get to them this year. In fact, the C# one, there is a community contributor doing it that is getting that. So we started to see, which for me is just music to my ears, like the community itself stepping up and say, hey, look, I mean, those are the drivers for those other languages, which is super cool. But you have to change the SDK because SQLite itself is the SDK. Like SQLite is a library. So there's no way to use it without changing the SDK. And some SDKs have a couple of warts, especially in the TypeScript universe, because they just make the assumption that because SQLite doesn't go over the network, and again, things just take a couple of microseconds. Better SQLite, for example, is a synchronous driver, right? So because they make this assumption, they're like, this will never block because this is a synchronous driver. And if you're using just the libSQL fork as a library, that can still hold true, so that's fine. But when you're using the libSQL over HTTP, like you talk to the libSQL server, then this is not true because now this request that on SQLite was a microsecond. Now this takes 20 milliseconds, so sync doesn't work very well. So there are a couple of warts in there, in the sense that like if you're coming from an SDK that is synchronous, you might have to just adapt your functions to be asynchronous and things like that. But by and large, you change the SDK.
What are the benefits of just using libSQL over SQLite without the Turso integration and replication? Like, what does it add besides just replication? Is there any other things that people might be interested in as a good reason to switch to libSQL over just using regular SQLite?
So the vast majority of the code that we wrote is around SQLite and is in the server, in the replication, and etc. And as I said, because that's the part that we want. What that means is that SQLite itself changes very little. Most of the time, we're just like adding a couple of hooks. And again, those hooks will be trivial to contribute to SQLite, but it is what it is. And we add a couple of hooks, and then we call those hooks from our Rust code in the server, for example. So like the vast majority of the code doesn't change the way SQLite behaves. Now there are a couple of things. So I would say that the delta is very little, which by the way is great for testing, because SQLite infamously has, or famously in this case, people talk a lot about how they're very thoroughly tested. They have 100% code coverage and etc. But you may not know that the test suite is actually proprietary. The test suite is not in the public domain. You see things you don't know. So we can't just fork it and like use their test suite because you can't just they won't give it to you. Which I think is a shame. But we write our own tests, but nothing like SQLite has. But we still have this thing that like as a principle, we should avoid making like very heavy changes on the database, on the core SQLite. When we do, we're very careful. And then we write a lot of tests about the things that we are changing and etc. I think the most significant change that we did on the core level is the fact that SQLite is very bad at changing schemas for columns. So for example, if you have a column that is marked as not null, but now you want to allow it to be null, or you want to change two columns at the same time, SQLite doesn't allow any of that. So again, you can change schema, but you can add columns, you can remove columns, etc. But changing a column, changing the type, changing the null property, and making something a foreign key, or those are all things that you cannot do in SQLite, and lots of people complain about it. Lots of our users complained about it. So we enough that we decided that okay, it's worth changing this. So we changed that, and then we have a couple of other changes that I think they're so niche and specific that I won't even mention because it would take me a long time to even explain what it is. But we have very small changes. One of them is in the row ID mechanism of SQLite, and so some small stuff like that. But I think the major one is that schema changes in libSQL are much better than in SQLite. Like our schema evolution capability is better than SQLite. So you might want to change just because of that, right? Just I don't care about HTTP, I don't care about replication, but this could be a factor for people to change.
Cool. So we've gone over libSQL in a lot of detail now. I think everybody knows the stage is set, but we've kind of glossed over what Turso is. So could you explain to us, like in concrete details, what Turso is and how it uses the edge to make all of this happen, and then maybe how like the multiple locations work?
So first of all, if I was starting this today, libSQL would not be called libSQL. It would just be called Turso, because this distinction doesn't help us. We're not the only ones. You have like Vercel, Next.js, etc. Like, so there are many companies but every time a company can have like the same name for everything is a lot better for awareness, is better for a lot of stuff. But once more, as I told the story, like it wasn't something that we planned, right? Just it was something that kind of happened. So we ended up in the situation. But I mentioned before that libSQL itself has a server mode, right? So in that server mode, you can spin up a server and then you can replicate it to another server that you run, which is a replica of the first server. So this is all part of the libSQL project. It's all there. And what that allows you to do is that the libSQL drivers themselves now can talk to either a file. And this is my favorite part. When you're developing, you just say URL :file, and you're developing there in a file. That's it. Nothing. But then when you want to push it, when you want to use the server, you change the URL to HTTP and everything else works as long as you're using your SDK, right? So it's an experience of like development to production that I think is unmatched. So again, but the server is part of the libSQL project. It's not something that is unique to Turso. What Turso is then like a managed server, a managed service that hosts that server for you. And then we're going to do things like security and backups and the usual stuff on managed service, like setting up certificates, and then you can encryption in transit and all this kind of stuff. So you could essentially think that this is a managed service of the libSQL server. And then we have the plans, the pricing, like it's a productized version of libSQL server. But if you want to run the libSQL server yourself, you can. Some people do. Like we have people in our Discord community that keep asking questions. So we know they do. We know they're running it. It's doable. It's possible. But Turso is our product and our service based on that. The replication is again present in libSQL server, but it essentially allows you to replicate. You have a primary server. So all the databases, now there is support like 10,000 databases. And again, 10,000 databases is a Turso limitation. Given the machines where we put you on the scalar plan, we're going to have higher plans in the future where you can up this limit. We already have customers running much more than that, but that will require like enterprise plans, right? But the 10,000 number is a limitation of the size of the VM we give for people on the $29 a month plan. libSQL has no such limitation. You can just create a billion databases or not, like however many you can fit in your file system. But yeah, replication is like that. So all of those databases, they share a same primary location. And then you select like a couple of replicas that you want to put anywhere. If you want on the SDK, you can replicate, as I mentioned, inside your own server. You can do that as well. You can replicate inside your mobile device. You don't have to be attached to our infrastructure to replicate, which I think is a fairly unique feature. I don't know of any other database company that does it. Like I can offer you replication, but I can offer you replication wherever you want, in your AWS server, on your mobile device, on your IoT controller. Like the sky's the limit. Just replicate the database there. And Turso does the work of keeping it in sync, right? So just that's the service that we run.
So you had a blog post about this. I think it was called like embedded replicas.
Yeah, embedded replicas is the name of the feature. Yeah.
Gotcha. So could you tell us a little bit more about like the mechanics, like how does that work?
Yeah. So like we're evolving this a little bit based on community feedback, but the way I said before is the following. You have a URL when you create your client, and the URL can be a file or can be an HTTP request or an HTTP address. If you put an HTTP URL in there, you're connecting to Turso over HTTP or libSQL server that you run somewhere. If you put a file, you're talking to a local file. Usually for Turso, and this is for Turso, the way it's configured, not only you have a URL, but you also have a token for authentication. Again, for libSQL server, you may not use the token, or you may if you set up your own infrastructure for authentication. So you're going to have those two parameters, URL and token. So you can add a third parameter now, which is sync URL. So when you add this third parameter, which is a sync URL, your URL becomes a file again, right? So now you're saying, hey, I'm using this file, and the sync URL is the URL from which I'm gonna sync. So what happens is that every time you write, this write doesn't finish until you sync the whole thing back. So you can always read your own writes. Right? So you're reading locally. The experience that if you are the only client, let's say you're doing this for performance reasons, and you are the only client, the experience is just this. You just use the database. Like the sync mechanism exchanges deltas. So you only have to, you don't have to always be downloading the whole database. Again, and we can only do this because of the hooks that we have in the SQLite now libSQL code to allow for that, right? So you're always receiving the new changes to the database. So if your server dies and it comes back again, in the initial sync, you're going to receive the full database. But then after that, you just like keep reading and writing and etc. And then you have a sync function, which is something that we're actually hiding because a lot of our users ask for that. You have a sync function that you can call in a background thread or in specific points, and that sync essentially says, okay, give me the changes since the last sync. And what that does is that like now you don't have to be the only writer. Like you can have 4 or 5 different machines. There was always a limitation of SQLite. SQLite only works on a single machine because it's just a file. Now you can have like 5, 6, 7, 10 thousands of different applications using the database. All of them have their own SQLite files on disk. They're all writing to the SQLite file, but they're all like periodically receiving the changes that the others are making through the sync mechanism. And the change that we're making now is that people just found too hard to spin up a background thread. And so we're adding to the constructor essentially something that says periodic sync, that you just say 1 second or 500 milliseconds or whatever. And then we do this work for you. And then every second, every 500 milliseconds, every whatever you set in there, we go to the Turso server. So your code is just like reads and writes. The SQLite code doesn't change, but you now have a database that is local, but is kept in sync with a remote master point.
That's really cool. I can see a lot of like local first use cases for this. That's a term that's getting tossed around a lot these days.
Local first is usually talking about like replicating parts of the data set. Like we don't have now. You can architecture it in such a way because, again, if you can create 10,000 databases, you can split the data set in 10,000 pieces and replicate. But one of the things that you can do, like inside Turso, the server, when you're using the server, all the servers are fully replicated. So you create 10,000 databases on a primary. When you create another region on Turso, all of those 10,000 databases are going to be replicated in that region. But when you're doing embedded replicas, you don't have that restriction. You can replicate only the databases you want. So you can have, for example, you can do some local first on that if you split the data in a sensible way. Or you can have a SaaS product with 10,000 users that has a mobile device. And then inside that mobile device, you replicate just the database for that user, right? So you don't have to replicate the databases in a pack. So it allows you to play with those architectures. There are things that, I'm very excited about that. I don't think we see a lot of usage on mobile yet. I think a lot of our users are still on the web and serverless because that's where we started. But that's a use case I like a lot. I mean, just get your 10,000 customers, separate them in different databases. And the database for that customer is likely not that big. It's like a couple of megabytes. So you replicate the database inside the mobile device of that one user. Right?
So you guys have essentially built one huge distributed database. That seems like a super hard problem. Like distributed systems in general are very hard problems, probably some of the hardest in computer science. What are some of the challenges you guys have come across while building this huge distributed database system?
So one of the things that helps us is that our consistency model and our replication model is fairly simple. Where like Scylla, as a contrast, was a more traditional distributed system in that sense. They had like multi-master and you can write from anywhere. Like those things are fairly hard. They require eventual consistency. So you always have those issues like, did you get the message? Didn't get the message? Like, what do we do? Turso is still a distributed system in that sense, but it's way simpler than what I think the audience will have in mind when you just say, bona fide distributed system. The reason for that is that, again, thanks to our replication hooks, The replication hooks exist in the SQLite write-ahead log. So the write-ahead log is essentially the stream of changes of SQLite, and that stream of changes is order. So we always have order. Because there's always a primary. So, they already simplify things a lot. There's always a primary. So the primary is the center of truth, like is the source of truth. And the primary pushes the updates to the clients, even if they arrive in a different order, because we are streaming the write-ahead log, there is a sequence number on this write-ahead log. So everybody receives everybody sees everything in the same order. Now, of course, there are disadvantages of this model. The reason people reach out for distributed systems is to have sometimes 5 nines availability, because that nodes can die at any time. But this is not how we run Turso, because first of all, we don't put, at least for now, we may do it for the free tier in the future, but we don't put different customers in the same VMs, right? So when you deploy something to Turso, you have your own VMs. Now in the VM, as I said, if you don't use any database at all, those VMs will still scale to 0 after an hour. They come back automatically, and sometimes that doesn't work. So this is a challenge, which is why we're considering in the future just putting the free tier users all in. Then it becomes more of a distributed systems problem. But there is no one big Turso machine that is like this distributed system. The way it works is, again, very traditional. You have your own VMs. Justin will have his VMs. You, Andrew, are going to have your own VMs. They're separate. If your VMs die or have a problem, Justin's not affected, right? So that happens a lot. Like one customer is down for whatever reason. It's not like the whole system is down. And then the replication is fairly straightforward. It's all like something with a primary. Everything is in order. So we don't have a lot of the distributed, the traditional hell on earth distributed systems problems with Turso, which is why we could, essentially the private beta of Turso was done in 2 months, right? So obviously the private beta, we evolved a lot since then. Like that has nothing to do, but it was very important for us, especially coming from a failed product, to validate as soon as possible. Okay, is this the thing? Because if it's not, we need to find the other thing quickly, right? And fortunately, we got 500 signups for the private beta in a couple of weeks with a landing page up. So we ungated for not all 500 actually ended up using it, but we could gauge interest from that. But again, we can move that fast, much faster than I think other distributed database companies, because our architecture is fairly simple. And it's a trade-off that I think people came to expect from SQLite. They will expect that we're going to be offering a simpler solution, but that's way cheaper, way faster, way easier to reason about than a fully distributed system. So the same trade-offs the SQLite has at the file level, we like to think that we're bringing the same trade-offs to the server, right? Yes, it is simpler. Yes, and we're the first ones to say, but you gain something with that simplicity. We can push features faster. The system is easier to reason about, and etc.
That's awesome. Yeah, this has been really cool. Turso is such an interesting technology, and libSQL seems honestly necessary, and I'm glad that it exists, because SQLite is such an enormously useful, beneficial to humanity technology, and it's nice that I hope that the community does rally around this as the place to make changes if they can't be contributed back. So one thing that we like to do before we move on to Tooltips is just ask a future facing question. We try to tailor this to each guest. But being that you've worked in databases and you're continuing to work in databases, what do you think the future of databases is?
So I actually wrote an article about that the other day. I think the future of databases will have less NoSQL and more SQL. Obviously, not everybody agrees with me, but I think a lot of the waves that are making SQLite, and Postgres is the clear leader on that, right? So I think the community by and large has abandoned a lot of the mid-tier NoSQL solutions, and Postgres is the real winner. We're trying to get our share of that pie. That's what we're trying to do to some extent with Turso, libSQL. But so far, the market share for Postgres seems to be a lot bigger. So I think Postgres will be dominant in that sense. And again, my reasoning for that is again, there's an article that I'm happy to share with the whole story. But I think a lot of people reach out to things like Mongo in 2010 just because you kind of had to scale out to run any pet shop store. Right? Just the machines became so much more powerful that today, like you can scale Postgres vertically and have like an uncanny amount of users. And in fact, you can have this uncanny amount of users even with SQLite, which is why we're betting. But Postgres is still more powerful. So I think a lot of the high horsepower use cases that had to use NoSQL even 5 years ago can be done with SQL today with just Postgres. One instance, that's fine. So I think we're going to see a lot more than that. NoSQL, in that sense, becomes confined to the specialty databases. So there's a lot of like specialty databases that are quote unquote like standard developers. They're just doing like stuff on the web, probably don't even know about. Again, if your life is all around the web, but there are a lot of databases. They're becoming more common now with like vector databases. Like vector database is an example of a specialty database. But you have time series, you have like column stores, you have like so I mean, those specialty databases I think will continue to exist and continue to thrive because time series, for example, by exploiting the pattern that your data is a time series, you can be so much more efficient than storing this at SQL. And you don't need the query capabilities of SQL because your data doesn't have relations anyway. So I think that just it's borderline, almost subjectively wrong to reach for SQL for that. And Scilla is one such example. Like the kind of use cases that you would run with Scilla, when you're just not going to run with Postgres. It's just not the same thing. So I think those specialty databases will continue to thrive. The middle of the market, which is essentially like the web developers, the mobile developers, the SaaS apps, and the day-to-day kind of stuff, will be essentially partitioned between SQLite, Postgres, and MySQL. I don't think that we will ever see a fourth kind of SQL. And what I keep thinking, I think lots of people will keep trying to create new query models. One example is SurrealDB. There is also another one that I think is fairly interesting, I think called EdgeDB. But I think all of those databases will ultimately fail. And in a sense, I think like Mongo was almost a happy accident because they were at the right place at the right time. I think the default for databases is to fail. And again, just because there's so much pull around SQL that it's just hard to break from this ecosystem. So I think all of those databases that are trying to do like not SQL, but for developers, like for normal day-to-day developers, will absolutely fail. And it doesn't. And again, this is not a statement about how elegant the query language is, how nice, how those things just don't win usually. And again, NoSQL will the NoSQL that is NoSQL for specialty purposes will continue to exist and thrive. And I don't think we'll ever see a new implementation of SQL. It's going to be Postgres, MySQL, and SQLite forever. And the new companies are all going to be like this in a different form. So if you look at the companies today in the database space, like PlanetScale, Neon, Turso, Supabase, Nile, like they're all like this in a different form. Like they're all in their Postgres, they're MySQL, they're SQLite, but in a different form. So I think this is the future of database companies, databases in general. And again, it could be wrong, but that's how I view it.
Sounds right to me.
And with that, let's move on to tooltips. So I'm going to share my screen. My first tooltip of the week is RS Doctor. It's from the team who does RS Pack, and it's a like tool suite to help you analyze Webpack and RS Pack bundles. There's currently a lot of very, very old, like decrepit projects that do this for Webpack, and none of them have ever really delivered on the promise of like truly being able to like debug my bundles easily. And I'm just super excited to see the RS Pack team try to tackle this, because like this is a huge missing tool in the front end developers tool set. And like I literally just want a tool like I can go to a file and be like, hey, why are you in my bundle? And there currently doesn't exist a tool that does that very well at all. So I'm hoping they can work towards that. But if you've been looking for a way to like find duplicate packages, see what's actually in your bundle and help debug that a little bit, I'd definitely give RS Doctor a look.
More Rust JS tooling. That's cool. Well, let's talk about some Zig tooling. So I found this today. It's MD4W, and it is a library, a Markdown library written in Zig that essentially allows you to stream HTML from Markdown parsing. So it like parses Markdown and then opens up a stream, and you can just stream HTML on the other side. Really, really interesting library. So this is I actually shared another tooltip by the same dev last week, the ESM run tool or whatever. So this is the same person behind ESM ESM.sh, the CDN or whatever. They're making a ton of great tools, but this one's really cool, and it compiles to WASM. So if you want to include it in any JavaScript runtime, you can. So yeah, really cool.
Yeah, it's super cool that they include a WASM part of it, that you can run it in a browser. And it seems pretty small for a WASM thing.
By the way, shameless plug, SQLite compiles to the browser as well. And we've been taking advantage of that, and not as much as I wanted, but there is there's a blog post coming up where we're going to go into more details where you can just run libSQL and stack blitz, right? So you just have this database. One day, I hope that we get to the point of speaking to like local first, and sure. I hope we get to the point that we can just ship the database to the browser for you. But the browser has its own complications to do, like replication files and etc. We're not there yet, but the WASM stuff is super interesting. It's a technology that needs to exist.
There's definitely a developer who did SQLite and WASM before the official project was kicking off. The developer of Actual Budget, what's his name? James Longs. Yeah, something like that. That was a really interesting project because he did SQLite and WASM, and then he used IndexedDB for the like backend store of like where it actually persisted or whatever. Yeah. And he had some like performance numbers or whatever said actually using it like this is faster than just using IndexedDB directly. And I was like, what? I guess just because you're writing the pages or the chunks or whatever. And
that project is Absurd SQL from James Longster. Yeah. Next up, we have val.town.
Yeah, so this is my tooltip for today. Look, I'm not a JavaScript developer. As we discussed in the beginning, I couldn't be further from that. I keep not understanding some stuff in this ecosystem. Maybe I'm the problem. Maybe JavaScript is the problem. I'll leave that up to the reader or listener. But I've been chatting with Steve for a while. Full disclosure, they do use Turso. So, I mean, there's just that's how I came to know what they're doing. But like even for me, who am not a JavaScript developer, I could get some JavaScript done in val.town. And I wrote a blog post about it because I love the way they position as well, which is essentially what if GitHub gists could run. So for me, like that don't know any of the ecosystem. Like, look, I don't know JavaScript, but I can look up a bunch of functions and like the code itself is easy to write. So you essentially write something like it's a GitHub gist, and it runs like that. You don't need anything. You don't need any deployment. You don't need any infrastructure. And it comes with a bunch of APIs that are pre-baked into the product. One of them is a SQLite API. So every user of the val.town platform has a SQLite database assigned to you automatically. You sign up for the server, you get a SQLite database. You can do whatever you want with that. That database is powered by Turso, which again, how I came to get to know the product. But super interesting. I mean, I'm running a Discord bot inside the company to manage some of the miscommunications that we were having before. We run our company on Slack and our community on Discord, which I guess it's becoming a normal thing these days. So I wrote a couple very simple bot to pass a couple of key messages back and forth. Again, without knowing any JavaScript, I just look it up and no deployment hassle, no nothing, just works. And again, you can have SQLite, you can have object store, you can have email, just like integrated in the platform. So like writing code it's an absolute breeze. Definitely recommend people checking it out.
Yeah, we had Steve Krause on in an earlier episode, and I meet up with Steve occasionally in New York. Yeah, it's a great product. They're an awesome team, and they ship really, really fast. So they're doing a lot of really cool stuff.
Okay, my next tooltip was something I've literally been playing around with today. Here at Descript, I've done a lot of end-to-end testing. Like we now have almost like 600 end-to-end tests, which is a lot more than 0 when I started. But recently, we started thinking about code coverage because like now a large part of our app is only touched by end-to-end tests. And it was surprisingly easy to get going. There's this npm package, Playwright Test Coverage, that like helps you with some of the instrumentation. You basically just plop it in for your at playwright/test import and get your test and expect from there. And then if you set up Istanbul in your Babel config, it basically just works. And like within like 30, 40 minutes, I had like a full test coverage report for everything that's touched. So it was like pretty easy to set up. And like now it's just like, it's so awesome to see like the fruits of our labor and see how many lines we've actually covered with these hundreds of tests.
That's wild. So how does it map URLs to files?
But yeah, you just do the normal like Babel Istanbul plugin. It does its instrumenting with its counters. And I haven't actually looked into what this does yet, but I think it just uses probably some Playwright APIs like before and after the tests to start something. So pretty cool. Like not much work either.
That's fun. That's awesome. Well, speaking of guests that we've had on the podcast, we had Runar back a ways back who talked about Unison, which is a really cool programming language. And they have just today released Unison Cloud, which is their cloud service. So I love to talk about Unison. I think it's like the future of programming. It's a very interesting language. But yeah, they launched their cloud service. Really, really easy deployments, kind of fun properties that Unison provides. So it's like very easy to do service to service communication. A lot of interesting stuff here. Also, their launch page is beautiful. It's like, it's so well designed. It's gorgeous. So really excited for them to launch that. Really cool to see more stuff in this space. I'm happy to see anybody who adds a solution that's makes it easier to deploy services.
Yeah, it really shows all the features that they have too. Like the service to service call, just being a function call is so cool. The immutable deployments, I love the platform. I hope to see it grow.
Yeah, I love how their deployments are also just a function call. It's like, here's how you deploy your code. It's just like, send this thing to the server. It's like, what? So fun.
Okay, our last tooltip.
So Cargo Dist is my other tooltip, and Cargo Dist is a godsend tool for Rust developers. So again, this is a language that I'm a lot more familiar with. One of the things I absolutely hate about Rust, again, I guess hate's a strong word, but I think Go in particular does a lot better, is the process of publishing a Go binary is almost perfect. Like Go is self-contained, it compiles to just the binary, just copy the binary, it works everywhere. There's no such thing as like dependency and etc. Rust had a bunch of ideas that this is the way to go, but it's just not there. I mean, the implementation is just not there. Shipping Rust binaries is very hard. It's very difficult in comparison with Go. That's part of the reason, by the way, why our CLI on Turso is Go, not Rust. Maybe it would be Rust if I knew Cargo Dist back then. So I mean, Cargo Dist is a tool that actually makes that process actually work. So Cargo Dist can generate a simple shippable binary in Rust, which is for me like revolutionary stuff. I mean, the Rust never could do well before. The way they do it is extremely interesting. Like they have some Zig build step that for the Rust binaries, super cool stuff. And not only that, Cargo Dist itself for you automatically generates like brewtaps, install scripts, and all of that. So again, not only they build a self-contained binary, but they build the whole infrastructure for you to publish your packages. And we've been using it in libSQL. So libSQL is built with Cargo Dist. And after we started building libSQL with Cargo Dist, oh my God, our lives became so much easier. Because before that, it's like, go get a runner for Windows and go get a runner for Mac OS, etc. And another one, now you need to build like the actual library for Linux ARM 64, no, Linux AMD 64. So we didn't support a lot of those targets because we just didn't have the bandwidth. Maintaining the install scripts was very painful. And again, the final binary for the server or for the CLI and etc. is just not shippable. It's just you have to go through brew, and this is just a complete change. So if you are doing Rust, definitely recommend check out Cargo Dist. This is how I will always be building my Rust projects from now on. Absolutely fantastic tool.
That's really awesome. That's so interesting. I have one crate that I've published, and I wanted to publish a CLI tool once, and it was too hard. I gave up.
Oh yeah, and I mean, if you're publishing to crates, is no problem, because like crates, it's fine. Like if you want to publish anything that is like a binary or a server or something, like take a look at this. I mean, this is
Really interesting.
better than
That's awesome.
sliced bread.
That looks really cool. Well, that wraps it up for Tooltips this week. Thanks for coming on, Glauber. This was a lot of fun. Very, very cool product that you're making, and it's awesome that you forked libSQL and like are now fostering a community around it. So thanks again for coming on.
It's absolutely my pleasure, guys. See you next time. See you around.
Yeah, so fun having you. Appreciate it.